Imagine a battery so advanced that your grandchildren could inherit the same device you buy today, and it would still be working perfectly. That's not science fiction anymore. Welcome to Curiosity AI, where we explore the scientific breakthroughs that are reshaping our world. I'm here to take you on a journey into one of the most extraordinary technological achievements of our time. Today, we're diving deep into something that sounds impossible, but is happening right now in China. A company called Betavolt has just achieved something that scientists have been dreaming about for decades. They've created the world's first commercial nuclear battery small enough to fit in your palm, yet powerful enough to run for 50 years without ever needing a charge. This isn't just another incremental improvement in battery technology. This is a complete paradigm shift that could fundamentally change how we think about energy, from the medical devices in our bodies to the sensors monitoring our cities. The implications are so profound that military strategists, medical researchers, and space agencies around the world are scrambling to understand what this means for the future. Let me paint you a picture of what we're dealing with here, and why this tiny device might just be the beginning of a new energy revolution. To understand why this is so revolutionary, let's start with a simple question. What if I told you that the same process that powers the sun could be miniaturized to the size of a coin? The Betavolt BV100 works on a principle called Betavoltaics. Think of it like a solar panel, but instead of capturing sunlight, it captures the energy from radioactive decay. Here's how it works in simple terms. At the heart of this tiny battery is a radioactive isotope called nickel-63. Now, before you worry about radiation, stay with me. This isotope naturally decays over time, releasing what scientists call beta particles, which are essentially high-energy electrons. These particles are constantly streaming out, like an invisible waterfall of energy. Betavolt's genius was figuring out how to capture this energy waterfall. They sandwiched the nickel-63 between two layers of synthetic diamond that have been specially treated to act as semiconductors. When those beta particles hit the diamond layers, they create an electric current, just like sunlight hitting a solar panel creates electricity. But here's the remarkable part. Unlike sunlight, which disappears at night or gets blocked by clouds, this radioactive decay never stops. It's like having a miniature sun that shines constantly for 50 years. The nickel-63 has a half-life of about 100 years, which means even after 50 years, it's still producing significant power. The battery itself is incredibly small, measuring just 15 by 15 by 5 millimeters. That's smaller than a penny, yet it contains enough energy to power a device continuously for half a century. The energy density is 10 times higher than conventional lithium-ion batteries, which means you're packing an enormous amount of power into an impossibly small space. Here's where this story gets truly extraordinary. In January 2024, Betavolt announced they weren't just making these batteries in a laboratory. They were mass-producing them. This represents a technological breakthrough that seemed impossible just a few years ago. The challenge wasn't just creating the battery, it was making it safe. Previous nuclear batteries used in space programs were massive, dangerous devices that required extensive shielding and could never be used near humans. Betavolt solved this with their diamond encapsulation technology. The synthetic diamond layers don't just convert the radioactive energy into electricity, they also provide perfect radiation shielding. The result is a nuclear battery that emits zero detectable external radiation. You could literally carry it in your pocket safely. Independent testing has shown that even if you shoot the battery with a gun or try to puncture it, the radioactive material stays completely contained within the diamond matrix. When the battery finally reaches the end of its 50-year lifespan, the nickel-63 has naturally decayed into ordinary copper, which is completely harmless. This safety breakthrough is what makes commercial applications possible. We're talking about nuclear energy that's safer than the lithium-ion battery in your smartphone, yet lasts 50 times longer. The scientific validation has been thorough. Multiple independent laboratories have confirmed the technology works exactly as Betavolt claims. The physics is solid, the safety testing is comprehensive, and the manufacturing process is now operational. The announcement of mass production sent shockwaves through military and intelligence communities worldwide. The strategic implications are staggering. China has effectively achieved energy independence at the device level. Imagine surveillance drones that can fly for decades without landing, or border sensors that operate autonomously for 50 years without maintenance. The military advantages are so significant that the U.S. Department of Defense immediately intensified its own Betavoltaic research programs. But the economic implications might be even more profound. The global battery market is worth over $100 billion annually, and it's built on the assumption that batteries need regular replacement. Betavolt is challenging that fundamental assumption. However, there's a catch. The current production cost is enormous. The nickel-63 isotope doesn't occur naturally and must be produced in nuclear reactors through a complex 3-year process. Industry estimates suggest each BV100 battery currently costs thousands of dollars to manufacture. China anticipated this challenge and invested heavily in isotope production facilities, ensuring they wouldn't be dependent on foreign suppliers. This strategic foresight mirrors their approach to rare earth elements and semiconductor manufacturing, where they've built complete supply chains to maintain technological independence. The Western response has been swift. NASA has expressed interest in nuclear microbatteries for space missions. The European Commission has announced significant funding for competing technologies. British and American startups are racing to develop alternative approaches using different isotopes and materials. Let's talk about how this technology will actually change your life, starting with the most personal applications. In medicine, this could eliminate one of the most dangerous aspects of having an implanted device. Current pacemakers need to be surgically replaced every 7 to 10 years when their batteries die, exposing patients to repeated surgical risks and costs of tens of thousands of dollars. A pacemaker, powered by BV100, could function for the patient's entire lifetime without intervention. The same principle applies to heart pumps, neurostimulators, hearing implants, and the emerging field of brain-machine interfaces. We're talking about medical devices that outlast the patients who receive them. For space exploration, the possibilities are mind-bending. NASA is already exploring concepts for swarm exploration missions, where hundreds of tiny robots powered by nuclear batteries could be sent to Mars or other planets, operating autonomously for decades while mapping surfaces and collecting data. Closer to home, imagine urban infrastructure that never needs maintenance. Environmental sensors throughout a city could monitor air quality, noise levels, and traffic patterns continuously for 50 years. Ocean buoys could track climate data across decades. Seismic monitoring stations could operate in remote locations where human access is impossible. The Internet of Things takes on a completely different meaning when the things never need their batteries changed. We could create truly permanent monitoring networks that outlast the people who install them. Betavolt isn't stopping with the BV100. The company has announced an ambitious roadmap that could transform this technology from a niche application into a mainstream energy solution. By the end of 2025, they plan to release a 1-watt version, which would be 10,000 times more powerful than the current model. This could power smartphones, tablets, or small drones. Imagine buying a phone today that your children could still be using decades from now. They're also experimenting with different radioactive isotopes to optimize for various applications. Strontium-90 could provide much higher power output, but with a shorter 30-year lifespan. Tritium offers a safer profile for consumer applications with about 20 years of operation. The cost challenge is being addressed through scaling and innovation. As production volumes increase and manufacturing processes improve, industry analysts predict the price could drop from thousands of dollars per unit to hundreds within the next decade. But perhaps the most exciting development is the potential for integration with other emerging technologies. Imagine electric vehicles where the auxiliary systems, sensors, and computers are powered by nuclear batteries, ensuring they remain operational even when the main battery pack is depleted. The Betavolt BV100 represents more than just a new type of battery. It's the beginning of a fundamental shift in how we design electronic systems and think about energy independence. We're moving from a world where battery anxiety dominates our relationship with technology to one where energy becomes invisible and permanent. The age of eternal energy isn't coming someday in the distant future. It's happening right now, in a factory in China, one tiny nuclear battery at a time. This technology will complement rather than replace existing batteries, but in specialized applications where longevity matters more than raw power, it could be transformative. The medical, military, and space industries are already taking notice, and consumer applications may not be far behind. The future of portable energy won't be about faster charging or higher capacity. It will be about completely eliminating the need to ever think about power again. Thanks for joining me on Curiosity AI today. If you found this exploration of nuclear battery technology fascinating, subscribe for more deep dives into the scientific breakthroughs that are reshaping our world. Next week, we'll be exploring another revolutionary technology that's challenging everything we thought we knew about the possible. Until then, keep questioning, keep exploring, and remember that the future is being built right now, one incredible discovery at a time.